Today's lesson is exponential applications. Okay, my learning target is I can use exponential functions to model and solve real-world problems by generating the equation, solving for the specified variable for exponential growth or decay or compound interest. Okay, so let's review. What is the exponential growth or decay model? This is a sub t equals a sub 0 times b raised to the power t, where a is the amount at time t, a sub 0 is the amount at time t equals 0, or my initial amount, my rate of change, my base is 1 plus or minus my rate of change r. And when I'm speaking about this, I'm usually talking about percent, but I need to use the decimal form in the equation. So for a growth model, I'm going to add the rate. For a decay model, I'm going to subtract it. And the 1 comes from 100% is as a decimal equals 1. So that's where the 1 comes from. And t is my time. Okay, so my compound interest formula is a sub t equals p times the quantity 1 plus r divided by n raised to the power n times t, where a sub t is the amount in the account after t years, p is my principal or my initial investment, r is my rate of interest. Again, we speak about this in percent, but we use a decimal in the formula. N is the number of times I compound per year, and t is the time in years. Okay, first example. Upon graduating from college, Ashley took a job with a starting salary of $40,000. She can expect a 6% raise in pay each year. Okay, so $40,000 is my initial amount, so that's called a sub 0. Since we're getting a raise, I know I have a growth. So my rate is 6%, which is 0.06 as a decimal. So my b, when I add 1 plus 0.06, I get 1.06 for my base. So my equation is 40,000 times 1.06 to the t. Okay, computer salary 1 year, 10 year, and 20 years later. So we're going to put our equation in y equals and go look in the table. So at 1 year, she would be making 42,400. At 10 years, 71,634. And at 20 years, 128,285. Okay, next questions. When will she earn $60,000? So let's just talk about this. So I have 2 types of equations that I'm asking, where I give you like my x value, and I ask you to solve for y. What is y? Or I can give you my y value and ask what is the x value. So there's just 2 types. It's one or the other. So this one is a little bit easier if we set up on the graph what it is we're looking for and how to put this in the calculator to solve. All right, so I want to graph these 3 points that we just got data for. So I'm talking about I want to divide up. So in my horizontal axis, this is going to be my time in years. And I need this for 20 years. So 5, 10, 15, 20. And my y-axis is going to be my salary. And it's going up to 128,000. So I'm going to count by 25,000. 25, 50, 75, 100, 125. So now I want to kind of rough in my points. So at 0, I had 40,000. 1, 42,400. At 10, 71,000. And at 20, 128,000. So I'm just kind of roughing in what my curve looks like. And the question's asking me, how long will it take to be earning 60,000? So 60,000 is about here. So I have a horizontal line here. So I'm going to put my original equation in y1 and my second equation, a horizontal line, in y2. It doesn't matter actually which one I put in which. So this is going to be 40,000 times 1.06 t. And I'm looking for this intersection right here. So in order to see the intersection on my, or to calculate the intersection on my calculator, I need to be able to save it. So you want to adjust your window settings. So set up the window so x min is 0 to 20 and y max is 0 to whatever, 130,000. And I'm going to do second trace. Second trace, what is it? Second trace, enter, enter, enter. So second trace, intersect, enter, enter, enter. Okay, second trace, intersect, enter, enter, enter. Okay, so this one is y equals 40,000 times 1.06 raised to the t. So when I do the intersection, I get 6 point, so I'm looking for this. So 6.959 years. So a lot of times when we're working with exponential, we round 3 digits. So I'm going to write that into second trace intersect and intersect, intersect, enter, enter, enter. All right, let's try another one. It's going to be pretty much the same process. I'm mostly trying to decide if I have a growth or a decay. So here's a caffeine example. If you drink a soft drink, the formula for the amount of caffeine in milligrams left in your body after t hours would be A sub t equals 100 times 0.86 raised to the power t. What is the initial amount of the coffee? So this is asking for A sub 0. So the initial amount, A sub 0, is 100. What is the rate of change as a percentage? So my rate of change, so first of all, I am less than 100 here. So I know this is going to be 1.0 minus 0.86. So I can find the difference, which is going to be 0.14, but it's asking it as a percent. So 14 is, this is 14%. And since I am less, it's called a decay. Since I'm a decay, it would be a negative number, so negative 14%. How much coffee is in the body after 5 hours? So I would substitute in T equals 5. So A at T equals 5 is 100 times 0.86 to the 5th. And this is about 47.043. And my units are milligrams. I guess I'm going to do this. When will the amount of caffeine in the body be less than 10 milligrams? So this is setting up my chart. I'm going to do the same process here. So I'm going to plot some numbers so I know the caffeine is my y-axis. Oopsie. So I have a maximum of 100, so I'm going to count these by 25, 25, 50, 100, 75. And these are in milligrams. So 25, 50, 75, and 100. And I know this is a decay, so exponential decay always approaches the x-axis. So I know I'm starting out at 100, and I am looking for specifically what amount? 10 milligrams. So I'm looking for 10 milligrams. So I want to know, when do I have 10 milligrams? This is going to be the y equals 10 line. So I know I'm going to have some kind of exponential decay that looks like this, right? So I want to set up for 5, 10, 15, 20. So I'm going to set up time in hours. I'm not sure what it looks like, but I'm just kind of giving myself an idea. I'm looking for this intersection right here. So this is my y equals 100 times 0.86 to the t. So I'm going to put this in y1, this in y2. I'm going to find my second trace intersect, enter, enter, enter. And I get t is about 15.267 hours. So again, we're going to round 3 decimal places when we're talking about exponentials. So here, this is my x equals a number, solve for y. And this is my question. This is my y equals a number, solve for x question. So they're one of 2 ways. When will the amount of caffeine in the body be 0 milligrams? So the answer to this is really never. And the reason is I have a asymptote here. So I approach the asymptote. But I don't ever actually cross it. So I keep decreasing, decreasing, decreasing. I'll have an insignificant amount, but I never actually have 0. All right, let's do a financial one. Oops. Here's the interest. Okay, say $4,000 is invested at an annual rate of 6%, compounded quarterly. So let's talk about compounding. So quarterly means My N value is 4, so I'm compounding 4 times a year. Monthly means N equals 12, so I'm compounding once a month. Or daily N is 365. So in this example, I'm compounding quarterly, so N equals 4. My rate is 0.06 as a decimal. And my principal, P, is $4,000. Write a formula for the amount in the account after T years. So this would be $4,000 times 1 plus, the equation is the rate, which is 0.06, divided by the number of times I compound, 4, raised to the number n to t, so 4t. How much will be in the account after 5 years? So this is A at x or t equals 5 is 44,000. 1 plus 0.06 divided by 4, and 4 times 5. So I get $5,387.42. Since we are talking about money, we're going to round to pennies. So this is my y equals question. How much would be in the account after 5 years if the interest is compounded monthly? So this one I'm changing the compounding rate. So compounding monthly means n equals 12. So A of 5 equals 4,000. 1 plus 0.06 divided by 12, and 12 times 5. So solving, I get $5,395.40. Next question, find the principal needed to have $5,000 after 10 years at 6.5% compounded monthly. Okay, so this one is asking me to find the principal. So what is the principal? So $5,000 is after 10 years. So this would be A at t equals 10. So my rate is 6.5%. So rate is 0.065 as a decimal, and compounded monthly means n equals 12. So setting up my equation, A at t equals 10 is 5,000. So this is the initial amount, which is the principal. So 1 plus 0.065. Oops. Divided by 12. And 12 times 10. Okay, so I'm solving for the principal. So to solve for the principal, I need to isolate P. So I'm going to divide both sides by 1 plus 0.065 divided by 12. 12 times 10. 1 plus 0.065 divided by 12. 12 times 10. So this is 1. So P equals $2,614.81. That's it.